Hey there, gearheads and techies. Adam Savage here, and today we're diving into the world of robots in electric car manufacturing. Imagine a factory floor, but instead of bustling workers, picture giant mechanical arms doing the heavy lifting. That's right, robots. These metal marvels have been around in manufacturing longer than you might think. Their story began in the mid-20th century with clunky, single-armed machines. These early robots were like the Model T of automation, basic, but revolutionary. They could perform repetitive tasks like welding and painting, freeing up human workers from danger and drudgery. These early robots were game changers. They could work tirelessly, 24/7, without breaks or complaints. But they were also limited. Think of them as strong, but dumb. They needed very specific instructions for every little movement. Still, they paved the way for the sophisticated robots we see today. And guess what? The automotive industry was at the forefront of this robotic revolution. Now let's talk cars. Building a car is a complex ballet of engineering. Thousands of parts, all needing to fit together perfectly. Enter robots, the ultimate choreographers of the automotive world. They brought precision and speed to a whole new level. They could weld body panels with pinpoint accuracy, install windshields without a smudge, and even paint cars in multiple colors with flawless finishes. This robotic revolution wasn't just about speed, it was about quality. Robots helped carmakers build safer, more reliable vehicles consistently. Need to build a sedan 1 minute and a pickup truck the next? No problem. Robots could handle the changeover with a simple software update. This flexibility made them even more valuable to car manufacturers, especially as consumer demand shifted and models changed rapidly. The electric car pushed robots to evolve even further. Now, electric cars are more than just a trend, they're the future of transportation. But building them presents a whole new set of challenges. The batteries that power these vehicles are incredibly complex and delicate. They require a level of precision that traditional manufacturing methods struggled to achieve. As demand for electric cars skyrockets, manufacturers need to ramp up production and fast. This is where robots become absolutely essential. Robots excel at handling the intricate tasks involved in battery assembly. They can place delicate components with micron-level accuracy, ensuring that each battery pack meets the highest standards of performance and safety. Picture this, a state-of-the-art factory gleaming with polished metal and buzzing with activity. Not human activity, though. It's a symphony of robotic arms gliding and swiveling with balletic grace. This isn't some sci-fi movie set, this is the reality of modern electric car manufacturing. Robots do the bulk of the work here, and they're really good at it. Think of a car assembly line like a carefully choreographed dance. Each robot has its own specific steps to perform, all perfectly timed and coordinated. Some robots lift and position heavy components like battery packs and electric motors. Others weld together the car's frame with laser-like precision. Still, others install delicate wiring harnesses and electronic components. It's a mesmerizing dance of technology, and it's all in the name of building the cars of the future. Robots also play a crucial role in handling the smaller, fiddlier components that go into an electric car. One of the coolest things about robots is their precision. We're talking about movements measured in fractions of a millimeter. Take laser welding, for example. Robots equipped with high-powered lasers can fuse metal parts together with incredible accuracy, creating seams that are both incredibly strong and visually perfect. This is essential for creating the lightweight yet incredibly strong structures that make electric cars so energy efficient. Robots can also apply adhesives and sealants with pinpoint accuracy, ensuring that every joint and seam is perfectly sealed. This level of precision is especially important when it comes to battery production. Electric car batteries are made up of hundreds, even thousands of individual cells, all wired together in a very specific configuration. That's why robots are used extensively in battery manufacturing. Electric car batteries are big, like really big and heavy. Trying to maneuver one of these things into place by hand would be a recipe for disaster. That's where our robot friends come in, with their brawn and their brains. They can lift and position these heavy components with ease, making sure they're perfectly aligned and secured. Some of these robots are massive, capable of lifting hundreds of kilograms without breaking a sweat. They're equipped with advanced sensors and control systems that allow them to move these heavy loads smoothly and precisely, without any risk of damage to the delicate components. And it's not just about brute strength. These robots are also incredibly agile. They can navigate tight spaces, reach around obstacles, and even work in coordination with other robots to complete complex tasks. This ability to handle heavy loads safely and efficiently is a game changer for electric car manufacturing. Building a car is one thing, building a good car is another thing entirely. That's why quality control is so important in the automotive industry, especially when it comes to electric vehicles. And guess what? Robots are amazing at quality control. Equipped with high-resolution cameras and advanced sensors, robots can inspect every nook and cranny of a vehicle with superhuman precision. They can spot tiny defects that would be invisible to the naked eye, ensuring that every car that rolls off the production line meets the highest standards of quality. Think of these robots as the Sherlock Holmes of the factory floor, meticulously examining every detail for any sign of a problem. This kind of data-driven quality control is essential for ensuring the reliability and safety of electric vehicles. Remember those early robots we talked about, the ones that were basically just big, dumb arms? Well, those days are long gone. Today's robots are smarter, faster, and more adaptable than ever before. They're not just following pre-programmed instructions, they're learning, adapting, and even making decisions on their own. Think of it like this. If those old robots were like calculators, today's robots are like smartphones. They've got serious processing power and they're loaded with advanced software that lets them do some pretty amazing things. One of the key advancements driving this robotic evolution is the development of more sophisticated control systems. These systems act like the robot's brain, allowing them to process information from their sensors, make decisions, and execute complex movements with incredible precision. Remember how we talked about robots being great at quality control? Well, a big part of that is their ability to see things that humans can't. Modern robots are loaded with sensors, cameras, lasers, tactile sensors, that give them a superhuman ability to perceive their surroundings. These sensors allow robots to see in 3 dimensions, measure distances with pinpoint accuracy, and even detect subtle variations in temperature, pressure, and force. Take vision systems, for example. Robots equipped with high-resolution cameras and advanced image processing software can now see even the tiniest imperfections in a car's paint job, or spot a misaligned component that's a fraction of a millimeter off. And then there are laser scanners, which create a 3-dimensional map of the robot's surroundings. This allows robots to navigate complex environments, avoid obstacles, and even work in close proximity to humans without any risk of collision. Tactile sensors embedded in robotic grippers can detect the slightest variations in pressure, allowing them to handle fragile components with the care of a human worker. Now let's talk about the real game-changer: artificial intelligence. AI is no longer just the stuff of science fiction. It's rapidly changing the way robots are used in manufacturing, and electric car production is at the forefront of this revolution. AI is essentially giving robots the ability to learn from their experiences and improve their performance over time. This means that robots can now handle even more complex tasks, adapt to changing conditions, and even identify and solve problems on their own. One of the most exciting applications of AI in robotics is machine learning. This allows robots to learn from vast amounts of data, identifying patterns and making predictions that would be impossible for humans to do. AI is also enabling robots to become more collaborative. The collaborative future: robots and humans working together. Now I know what you might be thinking, are robots going to take over all the jobs? It's a question that comes up a lot, and it's an important one. But here's the thing, the future of robotics in manufacturing isn't about replacing humans, it's about empowering them. The reality is that robots and humans excel at different things. Robots are great at repetitive tasks, precision work, and handling heavy loads. Humans, on the other hand, are better at problem-solving, adapting to changing conditions, and thinking creatively. The future of electric car manufacturing lies in finding ways for robots and humans to work together, each leveraging their unique strengths. This collaborative approach not only improves efficiency and quality, but also creates a safer and more engaging work environment for human workers. Tesla, the trailblazers. When it comes to pushing the boundaries of robotics in electric car manufacturing, Tesla is in a league of its own. Elon Musk's company has been a pioneer in embracing automation, turning its factories into showcases of cutting-edge robotics. Tesla's gigafactories are like something out of a sci-fi movie, with massive robots working in concert to churn out electric cars at an unprecedented scale. These factories are designed from the ground up for automation, with robots handling everything from stamping body panels to assembling battery packs. One of Tesla's most ambitious robotics projects is its Alien Dreadnought production line, aimed at fully automating the assembly of its Model 3. While the system hasn't quite lived up to its initial hype, it highlights Tesla's relentless pursuit of automation. But Tesla's approach to robotics goes beyond just replacing human workers. The company sees robots as collaborators, working alongside humans to improve efficiency and quality. Tesla's robots are equipped with advanced sensors and AI systems that allow them to work safely and effectively in close proximity to humans. The Volkswagen Group shifting gears. Volkswagen is transitioning to electric vehicle production, leveraging robotics for efficiency. Robots handle tasks from welding to battery assembly, ensuring quality and safety. The MEB platform is a key initiative, allowing flexible electric vehicle production. Collaborative robots, or cobots, assist human workers, enhancing productivity. BMW, known for its luxury vehicles and commitment to innovation, is also embracing robotics in its electric car production. The company is using robots to enhance quality, efficiency, and flexibility in its manufacturing processes. BMW's production lines feature a mix of traditional industrial robots and collaborative robots, each chosen for their specific strengths and capabilities. The company is using robots to automate a wide range of tasks, from welding and painting to installing complex components like battery packs and electric motors. One of BMW's key areas of focus is using robots to improve the ergonomics of its production lines. Collaborative robots, for example, can assist human workers with physically demanding tasks, reducing the risk of injury and improving worker satisfaction. BMW is also investing in AI-powered robots that can learn from data and improve their performance over time. These robots can adapt to changing conditions, identify and solve problems, and even anticipate the needs of human workers, making them invaluable assets on the factory floor. While established automakers are ramping up their robotics efforts, a new generation of electric vehicle startups is also embracing automation from the get-go. These companies are designing their factories and processes around robotics, challenging traditional manufacturing norms. Companies like Rivian, Lucid Motors, and XPeng are leveraging advanced robotics and AI to create highly flexible and efficient production lines. They're using robots to handle everything from stamping body panels to installing interior trim, achieving impressive levels of automation. These startups are not burdened by legacy infrastructure or traditional manufacturing mindsets, allowing them to embrace innovative robotics solutions more readily. They're using robots not just as replacements for human workers, but as tools to enhance creativity, quality, and speed in their manufacturing processes. This new wave of electric vehicle manufacturers is proving that automation can be a key enabler for innovation and agility in the automotive industry. The robotics revolution in electric car manufacturing isn't just about big-name automakers and well-funded startups. Advancements in robotics technology are making automation more accessible and affordable than ever before, opening up new possibilities for smaller companies and even research institutions. Collaborative robots in particular are becoming increasingly popular due to their affordability, ease of use, and ability to work safely alongside humans. These cobots are being used by a wide range of companies and organizations, from small businesses to universities, to automate tasks, improve safety, and accelerate innovation. The democratization of robotics is enabling a wider range of players to participate in the electric vehicle revolution, driving further innovation and competition in the industry. The cost of progress investing in the future. All this amazing robotics technology doesn't come cheap. Building a state-of-the-art electric car factory is a massive investment. We're talking hundreds of millions, even billions of dollars. But investing in robotics is about investing in the future. Robots may have a high upfront cost, but they save money in the long run. They work faster and longer than humans, without needing brakes. They don't make mistakes, reducing waste and improving quality. Bridging the skills gap. Training the workforce of tomorrow. Now let's talk about the elephant in the room jobs. Whenever the topic of robots in manufacturing comes up, it's inevitably followed by concerns about job displacement. And it's true, some jobs will be automated, but it's not the doomsday scenario some people paint it to be. The reality is that the rise of robotics is creating a whole new set of job opportunities. We need skilled technicians to program, operate, and maintain these robots. We need engineers to design and build the next generation of automation systems. And we need data scientists to analyze the mountains of data these robots generate. The problem is we don't have enough people with these skills right now. There's a significant skills gap in the manufacturing industry, and it's only going to get wider as automation becomes more prevalent. That's why it's crucial that we start investing in education and training programs to prepare the workforce of tomorrow. We need to equip people with the skills they need to thrive in a world where robots are increasingly common in the workplace. The ethics of automation balancing progress and people. Let's talk about the ethical considerations surrounding automation. As we hand over tasks to robots, we must consider the implications for workers and society. Job displacement is a major concern. Displaced workers need access to retraining and support. Bias in AI systems is another ethical issue. Biased data can lead to discrimination. We need ethical guidelines for AI to ensure fairness. Automation impacts worker safety and well-being. Robots can reduce injury risks but must prioritize safety. Section 4. The adaptable factory. Staying ahead of the curve. The world of electric car manufacturing is constantly evolving. New technologies are emerging at a breakneck pace, consumer demand is shifting, and competition is fiercer than ever. In this dynamic environment, flexibility is key, and that's where robots really shine. Unlike traditional manufacturing equipment, which can be expensive and time-consuming to retool, robots can be easily reprogrammed and reconfigured to adapt to changing production needs. Need to ramp up production to meet a surge in demand? No problem. Just reprogram the robots to work faster or add more robots to the line. Need to switch production to a new car model? Again, no problem. Just reconfigure the robots with the new tooling and software. This adaptability is what makes robots so valuable in the fast-paced world of electric car manufacturing. They allow manufacturers to respond quickly to changing market conditions, stay ahead of the competition, and ultimately bring better electric vehicles to market faster. But building an adaptable factory goes beyond just investing in the latest robots. It requires a fundamental shift in mindset, embracing flexibility, collaboration, and continuous improvement as core values. The electric car manufacturers that can successfully navigate these challenges, embracing automation while addressing the ethical and workforce implications, will be the ones that define the future of mobility. Section 1. The road ahead, paving the way for a sustainable future. We've covered a lot of ground today, from the clunky robots of the past to the AI-powered marvels transforming electric car manufacturing today. It's clear that robots are essential for meeting the surging demand for electric vehicles and driving the transition to a more sustainable future. Think about it. Electric cars offer a cleaner, greener alternative to gas guzzlers, but they're only part of the solution. We need to build them in a way that's sustainable too. That's where robots come in. Robots can help minimize the environmental impact of electric car manufacturing in several ways. They can work with incredible precision, reducing waste and material usage. They can operate with lower energy consumption compared to traditional manufacturing equipment. And they can even help recycle and reuse materials, further reducing the industry's footprint. But it's not just about building greener cars, it's about building a greener future for everyone. As we transition to a more sustainable economy, robotics will play a vital role in creating new jobs, boosting innovation, and improving our quality of life. Beyond efficiency, the human touch in a high-tech world. Some worry robots will take over, leaving humans out, but that's not the case. Robots can make us more human. They excel at repetitive, dangerous, or precise tasks. They work tirelessly without complaint. But humans have creativity, empathy, and innovation. Robots free us to solve complex problems and connect. We tap into our creativity and passion, like artisans crafting custom car interiors, or engineers designing safer, sustainable vehicles. Section 3. Fasten your seatbelts. The future is electric, automated, and awesome. So, what does the future hold for robotics in electric car manufacturing? We're talking about a world where robots work seamlessly alongside humans, where AI-powered systems optimize every aspect of production, and where factories are as much about innovation as they are about assembly lines. Imagine robots that can learn from their mistakes, adapting to changing conditions, and even anticipating problems before they occur. Imagine a world where electric cars are not just a luxury for the few, but an affordable and accessible reality for everyone. This is the future that robotics is helping to create. A future where technology empowers us to live more sustainably, work more creatively, and explore new frontiers of innovation. But it's not just about the technology, it's about the people who are driving this revolution. It's about the engineers, the programmers, the technicians, and the dreamers who are constantly pushing the boundaries of what's possible. It's about their passion, their ingenuity, and their unwavering belief in a better tomorrow. And that, my friends, is something worth getting excited about. So buckle up, because the future of electric car manufacturing is going to be one heck of a ride.